Thanks, everyone. Thanks for coming. The idea today is to give a brief overview of MDS. We've got 4 of our stream leads here, I think Fred had just appeared. There's Fred. So we can talk about the general program, but also about specific streams, what to expect when you're here in Durham, both life in Durham, the degree, and perspectives for after you graduate, careers. So essentially, let us know what you want to hear about. So the first thing I would like you to do is, can you please write in the chat which stream you're interested in, if you have chosen one? Otherwise, just type in MDS, so that'll be fine. So I'll drop a message on the chat. What I'll do is I'll give an overview for the whole program, and then depending on what you're interested in, we'll break into smaller groups, and you can chat and ask questions about the specific streams as well, or life in Durham, whatever you're interested. Okay, so thanks a lot. So I'll introduce myself. So I'm Camilo Caiado. I'm the Director for Interdisciplinary Postgrad Studies in the Faculty of Science and the Director for the Master of Data Science. We got 4 of our stream leads here. I'm going to ask them to say hi and let us know which department you're from. So first one, Jun Li on my top left.
Junli Liu from the Biosciences Department. I'm the lead for the bioinformatics and biological modeling stream.
No, thanks, Jun Li. Jen?
Hi, everyone. I'm Jen Badham. I'm in the sociology department, and I'm the lead for the health specialization of the MDS.
Great. And Jiraj?
Hi, I'm Juraj Meziorski. I'm an assistant professor at the School of Government and International Affairs, and I'm the stream lead for the social analytics stream.
And Fred, are you with us today?
Sorry about that. I had to change laptops. The previous one, the camera wasn't working. I thought that's going to be a bit disappointing. Hello, I'm Fred Worrell. I'm from the Earth Sciences Department, and I'm stream lead for Earth and Environment.
Yep, we have another stream lead, Peter Hesling. He can't be here today, but if you want to ask specific questions about digital humanities, you can talk to me, but I can also organize one-to-one chats with, with everyone, to be honest, if you don't feel comfortable asking questions in this setting. And for 2024, we'll also 2025, that's next year, we'll also have a new lead for MDS Heritage called Dawn Lawrence. But for now, I'm going to bore you a little bit with a few slides to talk about MDS overall. Then we'll work through, I can see that there's quite a lot of variation on what people are interested in, which is really good. Quite a lot of bio and health chats coming through. So we'll definitely split into groups and talk about that later. So I'll share screen now just to give an overview of the degree, and then we can follow up. And then Jun Li can share all his interesting anecdotes about bioinformatics and biological modeling as well at that point. Right, so hopefully that screen is visible. My computer claims to be. Yeah, so you've met most of the team here today. We have a learning and teaching team that works alongside us, Alex and Audrey. If you have emailed PGMDS, you have already communicated with them. Some of you have already emailed me as well, and we're doing our best to respond to your emails as fast as we can. You feel free to continue to drop us notes on PGMDS or Unibuddy, and we'll follow up as possible, as fast as we can. So Jen later will put on the chat the email for PGMDS, and there'll be a slide where you'll see the information that's needed as well. So at the moment we have 6 streams. So we have the main MDS, and that's the stream where you're focusing on leadership around data science. You have MDS bioinformatics and biological modeling, where you're focusing on bioinformatics and molecular biology more broadly. Digital humanities, as the name says, so anything to do with generative art, text analysis, that's there. Earth and environment, GIS, space and time, time series analysis, and broad applications in earth sciences. health informatics, understanding how different health systems work and how data flows through them, and modeling techniques like epidemic modeling, HBMs, and so on. And then social analytics, where you're starting to think about what if we need to create a policy in the back of a model, a full stack research design, causal inference, which are essential for this. In MDS overall, you learn all the skills that you would expect a data scientist to learn. So techniques around, well, the basics from statistics up to machine learning, text mining, data visualization, and so on. Within streams, you learn with the flavor that's associated to that specific stream. The degree itself is quite flexible and it's adaptable depending on the background that you bring with you. So we have core modules that are available to all streams, and depending on, say, how much programming you've done on the past, or if you haven't done any programming before, you take Introduction to Computer Science. But if you already know how to code in Python, we'll find an alternative for you. Introduction to Maths for data science, so trying to understand the basic techniques that come before you can use, say, a neural network or a random forest. It doesn't matter if you haven't seen maths since your A levels, we'll bring you up to the skills level that we require to teach you statistics and machine learning more broadly. But of course, if you already did maths, especially calculus and linear algebra before in the previous degree, you don't have to do that. That's part of the registration process. We'll look for another alternative. Then there's Introduction to Statistics for Data Science. That one is completely non-negotiable. Everyone does that because that's where you're starting to learn the principles of how to behave as a data scientist. And even if you have seen classic statistics before in a previous degree, it's unlikely you have learned how to present statistics in a data science context, especially when you have stakeholders that need to be engaged with the methods that you need to understand. So there's a good deal about leadership as well built into that. Then there are a series of other modules I'll talk through in a second. And then when you're getting closer to the end of your degree, well, just before summer, you're going to bring your project topic that you would have been assigned by that point, and you're going to work with our anthropology department to think about the ethical implications of the project you're going to conduct your literature review, trying to think of the limitations, any biases that would come through, and at the same time you're working on your data science research project alongside stakeholders from across the university, where you're going to be the data science expert and your supervisor will be an expert in the area that you're applying data science to. So, for example, you might be working with someone in chemistry and you're running experiments with them, collecting the data. So they are an expert in chemistry, but they're not an expert in data science. That would be for you to bring your data science knowledge to now try to understand the data in that context. And that holds for projects across all departments. At the moment, we have 17 departments from geography to sociology to English literature to maths. So everyone is offering projects across the board at the moment. So the main MDS is probably what most of you would have applied to. It's fine if you want to stay on main MDS, but please do think about streams because that can be quite relevant depending on which careers path you want to take. So the core modules here are ethics and bias in data science. That's delivered by computer scientists that live in the philosophy department. Strategic leadership from our business school. So trying to think about different formats of leadership and how to communicate data science in the framework that's most relevant for where you're working. Machine learning, pretty much everyone takes that module. So building up from basic models all the way up to how do you build a neural network from scratch, how do you program a random forest, but also how do you explain those models to people, how do you assess the quality of your models and so on. Then programming for data science, that builds on Introduction to Computer Science. You learn how to scrape data, how to start to think about data structures, and more advanced coding in general. And then the optional modules that you can pick and choose. Here, a couple of them, they're interesting. So text mining and language analytics, if you want to think about NLP, so natural language processing, and other neural networks that build up the principles of LLMs, data exploration, visualization, and unsupervised learning. So both data presentation, but also a little bit more around cluster analysis and other unsupervised type models, and multi-level modeling, which particularly we recommend for the health and the social analytics stream. Then we start to talk about streams. So digital humanities is our first stream, and that is essentially a very hot topic at the moment, especially with the essentially explosion of generative AI, but also thinking about digital humanities more broadly. It's not just about Gen AI, it's also about how do you process large amounts of text, trying to understand trends over time. For example, how would you link Terry Pratchett to H. Wells and so on. So trying to think about actually, I was in a panel yesterday where I had the English department to the computer science department discussing digital humanities more broadly. And one of the projects that they were looking at is how to personalize news so that it's suitable to the reader, but also ensuring that the news that you're reading are actually both truthful, but also tailored for you. So how do you balance trust and quality with personalization? But also one of them were interested in analyzing poetry, and at which point did poetry change the from its core topic, poetry written to women versus poetry written to God. So there's been over the centuries a transition on what poetry was targeted at. So those are all interesting things to explore under digital humanities, and flavors of modules that you can take as optionals. They're also available to other streams like computer music, data science applications of archaeology, and qualitative approach to digital humanities that's delivered by the English department. So you're going to have the chance to apply computational quantitative techniques to cultural data across the board, across centuries, apply machine learning techniques to literature, language, art, music. But the key there isn't, the applications are interesting, but all the skills you're learning are transferable, and you're going to be able to bring them into the real world as well. And because it's a very long module, you have the opportunity to design your own project as part of that module as well. So now we'll move to health. I'll let Jen talk through the health stream now.
Hi, everyone. So the health stream, basically think of it as having seven modules in common with the main MDS. So your first term is essentially identical. But then in the second term, some of the modules that the main MDS students do as compulsory modules are actually electives, and you are required to do 2 health-specific modules. So those health-specific modules are health informatics and clinical intelligence, which talks about where does health data come from, what does it look like, what are the characteristics of health data, so that you can actually work with data that's in the health system. Then the other one is about models and methods for health data science. So that's specialist specialist analytical techniques that are used in health data science. So that sets you up to be able to walk into health data science jobs. Health is a massive part of the economy and is growing. So they're crying out for people who can work with data. And I was talking with one of last year's students this morning, and she was saying she's starting to apply for jobs now, and she's seeing that the sorts of things that we were doing in the module are things that she can actually see in the job advertisements and in the interviews, that these are the sorts of things that they're asking about. So it's very directly connected to the sorts of things you do in data science jobs in the health system. You also get very proficient in R, which is a very important data analysis language.
Thanks very much, Jen. I'll hand over to Jiraj to talk about social analytics next.
Hi, so just like the previous stream, most of the modules in the social analytics stream are shared with the main MDS. What sets us apart are two core modules. One takes place in the first term, the other takes place in the second term. In the first term, it's the research design module, and in the second term, it's the causal inference module. The research design module focuses on being able to carry out data science research projects from start to finish. So from deciding what is the research question or questions, what is the data to use and what are the methods to use, and how to navigate various trade-offs in that, until the final stage, which is presenting the findings to audiences that may not be willing to engage with the technical detail. The second term module, the causal inference module, focuses on estimating effects of causes, of decisions, and actions that we can take. For example, in many industries, decisions on what exact product design to use are tested using methods from the causal inference toolbox. This goes from things like randomized experiments or randomized control trials, also called A/B tests in some sectors, to some cutting-edge methods for causal inferences with observational data and estimation of individualized treatment effects and optimal treatment allocation. Now, the illustration that you can see here is from one of the readings from the research design module. This is a recent article in which they use a randomized experiment in the streets of New York, and machine learning plays in this experiment in that the experiment is recorded through CCTV cameras which were already there, and the feed from these cameras was analyzed using algorithms to better measure humans' reactions to the experimental treatment. Thank you.
Right, thanks very much, Jiraj. And we move now to bioinformatics and biological modeling with Julie.
Hello, everyone. We provide the two modules. You can see here on the top, this is bioinformatics, which is a compulsory module for this stream. Bioinformatics is going to basically summarize, if you like, or provide the skills in data analysis. So we will analyze a large scale data sets, such as DNA sequencing, RNA sequencing, this kind of data. Modeling in molecular biology will provide the skills in modeling, mathematical modeling. So if we basically we use the data, we can derive the network. We use the network, we can develop mathematical models. Then we can analyze those models, try to understand the biology better, if you like. We also provide projects, different types of projects. This one showing here is about how COVID could cause the gene expression in human cells. So basically, we can identify something like 435 genes upregulated or something like that. So basically, if you go to this kind of skills, this kind of stream, we can provide this kind of skills. Thank you.
Great, thanks very much, John Lee. And now Earth and Environment with Fred.
Coming back on. Yeah. Hello, my name's Fred. As you said earlier, I lead the Earth and Environment. So again, rather like the other streams, we have two modules that are distinct. One is data analysis in space and time. The other one is data science applications. So the sorts of things we look at that you've probably heard of are things like geographical information systems. In fact, that's where we start. Thank you. Spatial information systems, GIS. So although the course is taught in Python and R, we also include GIS. So you will be looking at things like ArcGIS Pro and also what is known as QGIS. So some other freer platforms. The second half will be is in time series analysis. So that's both discrete and continuous systems. It so happens that the animation at the bottom is the obvious thing to work on, and that is particularly climate time series. Though the picture of the cricket match is the alternative. I wanted to provide an alternative to showing just looking at illustrating time series analysis by looking at climate and predicting weather, was that actually predicting the outcome of things like cricket matches. So for example, if you're following the current World Cup, you might be actually understanding why it is that England won last night. Now, the other things, as I said, is an obvious example of most of the spatial information we deal with, and a very big producer of data is remote sensing. So in the second half, we do look at both passive and active remote sensing. And we're very keen that although you might spend the practicals and workshops with us looking through data not dissimilar to that animation that's coming up, which is the the warming trend in Durham over the last century. Durham has got 1.6 degrees warmer on average since the beginning of the 20th century, is that we'll actually get you to collect some data. And that is that we call the data camp. We want to actually illustrate how often difficult and how messy real data is. You'll see that in other streams, but we want to actually get you to collect some. So we will actually spend some time in the field with a range of bits of kit that we'll then ask you to actually put together. So indeed, there's the quote at the bottom. If you want to know why a cricket match is like a rainstorm, this is the stream for you. Thank you.
Right, thanks very much. So those are the streams we have for MDS. So as promised, here's the contact card. You can scan the QR code to get to the application stuff. The key email address here on this slide is pg.mds@durham.ac.uk. If you send us an email there, you can ask us to, I don't know, you might want to talk about your application, you might want to talk about streams, or you just want to ask questions or get in contact with the stream lead. That's perfectly fine. Email us and we'll arrange for that to work and give you the information you need. I appreciate that most of you haven't been to Durham before. So Durham is, well, a relatively small city in the north of the UK. We're about 15 minutes from Newcastle, not too far from Manchester if football is the thing you like to go watch, and 2 hours from London and about an hour and a half from Edinburgh. So nice little city with plenty of cultural things going on, good heritage site, very safe, because I appreciate that that's a thing for some of you guys that come from big cities. So you feel like that the whole city is your home to an extent. Thanks everyone for coming along. So if you want to ask us more questions, or if you want to have a one-to-one chat with one of us, send us an email to pg.mds@durham.ac.uk. The email is on the chart, and very happy to continue the conversation, talk to you about module choices, life in Durham, whatever you think it's most useful. I'm very much looking forward to seeing you here in a few months, if not earlier. I mean, if you come visit Durham over the summer before you join MDS, let us know, and happy to have a coffee and say hi to you. So definitely see you soon, hopefully.